So welcome to the AT Construction Podcast, and I'm super excited today to have Neil Freidberg on. Welcome, Neil.
Well, thank you for having me.
So Neil and I met, and just a little background, Neil's the Building Science Manager for OSB Technology at LP, Louisiana-Pacific, and we met on site on one of our projects, and your education, your knowledge intrigues me a ton, as we've tried to get more involved in building science here at AFT, and I know many builders across the country, like this is something that we see as an industry moving forward and advancing, and you've been a big part of that. So, Neil, we're excited to have you on.
Yeah, thank you for having me. It's a pleasure.
So let's start here. One thing, we just did a video. Matt Reisinger was out here, and we did a video. We have a ton of LP product on the net zero house we're doing with Marco Liberté, as you know. And the question's often asked, because we use this term called thermal bridging, right? Thermal breaks, and people, especially if they're not in the building industry, and even those maybe coming up, like, what is that?
Yeah, so let's break it down a little bit further back, kind of like middle school science, real quick. So heat transfers in three methods: conduction, radiation, and convection. So when we're talking about specifically about thermal bridging, it's basically a connection through an assembly where it is a majority conductive, right? So it's the outside sheathing warming up, transferring that heat through conduction, through touching each other, through some studs, whether it be metal, wood, to the inside when that heat is on the outside. Or vice versa, like if you're in a cooling climate, in a climate where you need heat inside, it's that heat escaping through studs to the exterior.
So just to break that down a little bit, it's really what you're trying to do, because there is a connection, right? And any of us understand this. So let's say if you have a steel column that's exposed on the exterior or wood, as you mentioned, that heat, that sun or the cold outside is beating on that, and it's transferring or bringing that heat through that material inside the house. And so really you're losing energy, right? Or you're losing, if it's, for me, it's easy, a hot climate. I'm in Arizona. We have very hot summers, 115 degrees. So sometimes people will notice, and maybe in cold climates, you may be by the window and you can feel that cold draft right at the window. Or in the hot climate, you may feel it hotter at a certain place in the home where there's not as much insulation, maybe on a second floor over a garage if it's not insulated properly, or an exterior wall.
Yeah, absolutely. So it's like that. So it's always high to low. Physics never changes, right? So these high temperatures are trying to come in. And all this affects the way the building performs, both in a thermal aspect, but then also it affects your HVAC unit, right? So it requires more cooling for an arid, hot climate like yours. It requires a lot more cooling. And honestly, I always tell people that when you're thinking about like the thermal bridging effect on a wall and your HVAC unit, your HVAC is really cooling your surfaces, and we, the people inside of that area, benefit from being there. So 75% of it is basically cooling all surfaces around the exterior of the building. 25% really the kind of where we are, the ambient air, and all that is affected by thermal bridging, air leakage. So all the things that you talked about really have like a huge effect on the way your wall performs. Thermal bridging is typically one of the easiest ones today to start actually taking care of, now that we have more and more codes that keep advancing.
It's interesting because, as you walk through this, Neil, for us, especially now, and this was something that, to be honest, I didn't truly understand, especially when I first came out of college and was in the building industry, but you don't realize that wood plays a key factor. And as you get into this, like they talk about advanced framing and designing the house where maybe the studs are 24 inches on center, Lewis 16, just that small change. Now you have more insulation, right? That is a stopgap for that thermal bridging, so that's less wood that transfer can happen. And just those small changes, right? Because really with that thermal bridging, to stop it, you're just trying to create these dead zones, if you will, or products that now impede that transfer of energy.
Yeah, absolutely. Yeah. So like when you're talking about going from 16 to 24 inch on center, you're really talking about almost a 8% reduction in thermal bridging, right? So when you go from that 16 to 24, that's how much energy you're gaining back by doing that. And I know when we're talking about percentages, it's not a lot, right? But in the accumulative, it starts becoming bigger, right? These, neighborhoods that are focusing on high energy thermal bridging, stuff like this, it really starts accumulating, and it actually benefits the grid overall, right? But it also benefits the homeowner whether it be energy bill or it benefits the home and the performance of that home.
It's funny because one of the best analogies I've heard, they said, imagine you're in Minnesota in February and it's like you have this amazing like down jacket, keep you super warm, but the zipper's down in front, right? And so you just let like all that cold air in. Essentially, you're trying to enclose, right? Just like our buildings are trying to enclose that. So what are some techniques? I know one of them, in Arizona that we're doing on the net zero house is that, and this is the first time I've done this, that you typically the slab, we're pouring the slab on grade. And so the exterior of the slab, that sun's beating on them, bring that heat into the home. Now we have foam, rigid foam on the slab. And so now it creates that dead zone, right? That sun beats on the foam and it can't transfer into the home.
So it's not so much it really slows it down significantly, right? So it's one of those things that comfort is comfort is one of the items that people can't really put a dollar amount on, right? Because it's such a subjective view. But regardless of hot and cold, I can't imagine walking barefoot in my house, not liking to walk around an area because my feet are cold or feet are hot, right? So these are like the benefits of that. But it's such a huge hurdle when you start focusing on where exactly that building can perform, right? So walls are always one of the things that we've talked about. We probably, beat to death on talking about walls, insulation. Slab is going to be the new hurdle, right? Slab in all climate zones is going to be the new hurdle. While in the northern climate zones, they've already had solutions for it, stem walls, insulating both in and out, right? It's the southern climates like yours, 3, 2, and 1 are going to start focusing on that. And it really does have a huge effect on the cooling and the comfort of that home.
You brought up climate zones. I think this is important, is that most people don't understand that there are actually zones that are built for our country, right? Climate zones. Walk us through what those zones are and how that's broken down.
Yeah, so if you're looking at like the map of the U.S., and for people who don't know, you can Google this. It's IECC climate zone maps. And what it does, it basically dictates county-wise, and it's not an exact science, it's a rough estimate. So we base it on counties, and what we do is based on those climates and those 30-year analysis, it dictates what level of climate you are in. So there's 8 climate zones, 1 to 8, and then there's 3 hot, humid, dry, and then marine, so A, B, C. So you can be in climate zone 1, 1A, and then you could be designing for areas in Minnesota, and what you're doing in that climate zone 1A won't work for climate zone 7 or 5 because it doesn't work that way, right? So one of the benefits of looking at like climate zones itself is to identify where you're building, how you're building based on those climates, right? So it allows you to understand where insulation matters the most, where comfort matters the most, and how your walls work, really, right? So in hot, humid climates, a majority of the time you're cooling your home, right? It may be a couple weeks out of the year you're adding some heat because you're not used to that below 70 degree temperature, versus like Minnesota where they're negative 20 degrees and they have to heat it to that 68 comfort zone. So it really does affect how we use and understand buildings based on those climate zones.
It's a good breakdown because I don't think people realize, even as you mentioned, you could be essentially the same climate zone, but it is different depending on the humidity, or if you're on the ocean front, as you mentioned, or in the desert, such as myself, where it's a little drier. As you go into California and coastal cities, right? I've been to Charleston and see how they build. I mean, they're factoring for so many different things, right? Because you have all the moisture in the air, you have salt water if you're along the coast there. And these things affect, the substrate and the thermal and building assemblies tremendously. And so you have to have a different process to build your envelope or house, as opposed to maybe me in the desert, that's dealing with a different factor or climate.
Yeah, so that's a great point. And, we can talk about those, but we also have to look at like the microclimates that exist even within the own climates, right? So like me, a building scientist, is trying to model a house or look at a house off the coast. I'm looking at higher pressures right off that water versus 20 miles inland. All of a sudden my pressure changes, right? So it could still be, really humid, really hot, but the pressure from the ocean alone can really affect it. And other things that we have to look at also are like the microclimates in like an area like Arizona, right? So one of the things that we as humans do, we like to make things pretty. we drop in man-made lakes or ponds in neighborhoods, right? And all of a sudden, that pond can actually start affecting some of the walls that have never really dealt with humidity during certain times of the year. So we have to look at all those little things.
That's interesting, and honestly, until you've said that, I've never thought about that here specifically in Arizona because, as you mentioned, I mean, it's a very dry, well, at least Phoenix, right? You could go a couple hours north of Flagstaff, and now you're doing something totally different where high elevation, snow, ski resorts. But as far as Phoenix in general, yeah, that is an issue. A lot of us are exposed to natural desert, but there are some master plan communities with massive man-made lakes and water systems, and that can make changes to just the building structure. And so for us as builders, like by not understanding, or designers or architects, by not understanding just immediately in our area, I mean, that can make a huge difference.
Yeah, it's huge. It really changes the way we have to look at buildings in general, right? It's no longer, okay, great climate zone kind of dictates the overall energy analysis, overall understanding of heating requirements, cooling requirements, basic wall design. But then when we start actually focusing on a single building, orientation starts mattering, the effect of the areas around it, right? We can get heat island effect if there's a ton of concrete. We can get these microclimates from ponds that really can start affecting, even just like the north side of a building, right? So let's say that pond is north of you and you have a southerly wind. All of a sudden, your north wall may even start seeing some moisture inside of it, right? In a stucco wall, moisture loves to stick in that.
Yeah, it's interesting that you say that because, I mean, you look back and maybe this gets into how complicated building homes can be, right? I'm often told that it's funny as you see, not to go sideways on this, but sometimes, through these social media platforms, we'll post something, right? And you have people like, oh, anyone could do this. If you know how to schedule, you could schedule on people. And the more that I've been in the building industry and more that I've owned my company, I realize how complicated each of these structures are that we're building, right? And it doesn't have to be some elaborate design, but I mean, just in general home building. And this is why building science is so important. I wanted to have you on because, and you bring up the stucco side, traditionally, especially in the 80s, 90s, early 2000s here in Phoenix, as they're just kind of blowing go, well, it's hot. They're not flashing windows. They're putting black paper up, right? There's no waterproof barrier. How, as you mentioned, stucco, it just saturates. It just sucks in water, and that could create major issues to the home itself.
Yeah, absolutely. So one of the things that we always look at is how can we implement better building practices in code in general, but also, in the local municipality areas, right? So we look at what happens, we see what fails, and we improve from here on out. But the things that I'm always talking to builders about is when, we need to look at how to make these buildings resilient, right? So as you develop a building standard for, let's say you're a home builder, you're like, I'm going to build this way. I'm going to always build this way. Well, that way may not work in other areas of even the same city just because of the way things change. And then if you're going to start looking at specific materials and practices, do you want to do something that's going to last 50 years, 60 years, right? Most homes are mainly designed between 20 to 30 now, right? It's basically pop it and go. When you're looking at builders as such as yourself, when you look and take in so much care and so much detail, we're looking at the new 100-year homes. We're looking to build the new historical districts now.
It's so important to say that because, and I think this is that point that's lost to a lot of, I don't want to say the lay person, but the person that's not as involved, right, as we are in the building process is that, you think about this if you don't have to be super political, but if you have any concern about, buildings that we're building, are they going to perform? Are they going to be sustainable? Are they going to last over time, right? Any of us that have done a remodel that's been through demo and you're tearing everything down, I mean, that can't be great, right? For any part of our society and our world. So, I mean, just to have any stewardship, if you will, of what we're doing, I mean, we should be investing in building science. We should be investing in technology that is going to make these homes last and help and deliver that message, especially to our clients.
Yeah, absolutely. That's one of the best things about working with you as a manufacturer. We get to, one, show off our product, but then two, we really get to talk about the benefits long term of our product, right? And how it's going to benefit the homeowner, the builder like you, and all the other items that come along with it, right? So it's never just, implement our product and then good job, and we walk away. It's implement our product, and here's how it benefits you. Here's how it benefits the homeowner, right? So one of the things that I always tell people, I'm currently looking for a house, so I'm going to use myself as an example. I'm looking through houses, going to new homes, going to older homes, and I'm looking at these things, and the salesperson or even our realtor is always like, "Oh yeah, look at the countertops," and I'm like, "I really care what's in the walls."
Yeah.
Like I'm like sneaking around with my infrared camera, looking at what's in the walls because I need to know how much money I'm going to spend to make my house better, both in an energy performance and everything else. Because she's always like, "Oh, these are beautiful counters." I'm like, "The counters are great, but I can change counters." It's really difficult to open up my walls and fix insulation. It's really difficult to open up my walls and add a WRB to the exterior, stuff like that. So I'm always analyzing these different things that go into a building. So it's always great when I'm working with builders to say, "Hey, look, we need to focus on the wall because things inside can always change."
So you made this comment, WRB, for those that are listening that do not understand what that is. Explain what a WRB is.
Sure. WRB is a weather-resistant barrier. So typically, if you're looking at an assembly, so I'm going to nerd out high level, though, I promise. So let's say we're building a home in Nashville, for example, right? So we have some sort of facade, could be siding, brick, etc. I'm always going to recommend, regardless of what climate you are in, if you want a long-lasting wall, you need a rain barrier. So you need some sort of gap that allows moisture and that can condensate on surfaces to escape using air. It's a nice passive system, correct ventilation, blockage, all that stuff needs to be there. But I'm always going to recommend a rain barrier. And then next would be some sort of WRB, which is the weather-resistant barrier, and that's going to allow for any bulk water that can get through your facade, can land on there and drip down or escape, and it'll prevent your structure from rotting, right? So then some sort of OSB panel, your thickness of wall by choice, depending on energy or climate, so 2x6, 2x4, and then your internal insulation in that cavity, and then gypsum on the inside, and then some sort of paint, right? So when you look at that wall, just that simple wall, there are so many variables that affect everything, right? So if I put a bad job of insulation, maybe moisture can find its way through a thermal gap or a thermal bridge point, and it can affect the load of the inside. Or your HVAC is oversized, and now you're short cycling, causing humidity from the inside to creep into your wall. So it's just one of those things that when we're looking at these walls, we have to look at every single segment, including the way to protect it from water, which is your weather-resistant barrier. Your facade does the majority of the bulk work, and then your insulation helps reduce heat transfer through that cavity, through that wall, and then, of course, the OSB to hold your building together.
So to that point, I mean, as you mentioned, right now we're dealing with, I don't want to say fighting, but we're dealing with Pinterest and Instagram and all these beautiful homes we're seeing out there. And yeah, the reality is, clients want to have more stone and more brick and, maybe like a faux wood exterior and stucco and concrete and all these different elements, right, are going into our buildings. And so it makes the building more and more complicated. And as you mentioned, that's the facade, right? The facade is a stone and brick that's installed. And, in a rainstorm or a monsoon, right, it's going to beat on there. A lot of that will drain off and, fall off the house. However, there's still quite a bit that's getting through that. And to your point, there's either an air gap or a ribbed rain screen or something, whereas water gets through that now it can drain out. And then even behind that, you still have more protection with the WRB, the weather-resistant barrier, which essentially now you're keeping all water out of the house, which is our biggest enemy.
Absolutely. And in fact, I always tell people, a majority of litigation ends up being water intrusion in homes, right? So while vapor, it can do damage over time, bulk water is your biggest enemy. So if you can keep the bulk water out and then manage the moisture, you tend to build a great wall.
And I love that we're having these conversations because one of the biggest challenges, especially from the builder side, it's really hard to dive deep. And you mentioned this going through your house, right? Because the realtors, the clients, they're looking at a beautiful range, a beautiful, the cabinetry, the countertops, the flooring. I mean, all the things that are easy to see, right, that we don't understand. And what's interesting, especially in the last few years, I feel that this has given us an advantage. Social media, podcasting, YouTube, all these different avenues to say, okay, have Neil talk about building sites, right? And we can go down this road of understanding how important this is. And I don't think people even then really thought about it till we go through COVID, and now people are concerned about the air they breathe, right? How healthy their home is. They're spending more time at home. What's the air quality of their office? These things are really important to people now. And so we have clients that are looking at this, and really they're listening and they're watching. And so it's really hard for me to say, okay, X client, yeah, you're going to spend quite a bit more, not a tremendous amount, but a little bit more to have either net zero home or, put WRB on properly, or, some of these thermal bridging and thermal break techniques. But the reality is, they get it now. So now we have clients that are willing to invest in that.
Yeah, that's great. There's always a lot of these hurdles, right? So it's always, when we talk about like the indoor air quality, it's not blaming one product over another or one solution over another, right? I can put the best HVAC unit in the world in a house that is leaky, right? All of a sudden, all the things that I'm doing to maintain air quality, comfort, is gone because it's all being lost in through the walls. Or vice versa, I can build a great wall and then put in a very simple bypass system without any sort of like heat recovery, and then all that effort's for naught, right? I mean, it does benefit you, but it's not going to be the ultimate solution for somebody, right? So, like, if we just focus on air leakage, right? If we want to talk about air leakage is this hyper complex item that is affecting your house from walls, ceilings, foundation, all the things that happen, right? So let's say we air seal your exterior walls. Well, now we have to look at foundation connections and your ceiling connections, right? So let's say we take care of those two items. Great, now we have a house that now is very tight. So what do? You as you exhale, you start building up CO2 in your house. You could build up other things. So you start looking at bringing in outdoor air in, right? So in areas like in areas like where you're at, an ERV is probably just a simple solution, right? It's an energy recovery ventilation system, right? You allow outdoor air fresh in, and you put it through this temperature exchanger, possibly humidity exchanger, maybe not in your area, more temperature for you, and exhaust some of the air out that was inside. So you're bringing in fresh air, bringing it out, right? So these two things that work together help maintain a good indoor air quality, right? It's a controlled system. You're controlling the amount of air that's leaking on purpose, and you're controlling the amount of air that's coming in on purpose. You can filter it. You can you can shoot some sort of you can shoot it through some sort of filtration system, whether it be like I'm not sponsored by them, but like a halo or some sort of blue light or UV light to help clear and purify the air. And then you can right-size your HVAC unit that way to make sure it's properly running continuously filtering out air. And then on homes like what you build, when you run your range, it needs to be able to make up that air that you lose when you turn on that range, right? So, I'm kind of getting in the weeds, but these are the complexities that builders have to deal with now, right? So it's no longer, I just need to put an HVAC unit. I need to put a wall together. It's, I have to think about all these things because the person I'm selling my house to is being affected by all these items.
Well, you're not getting in the weeds. And this is something that everyone needs to understand is that, as you mentioned, as we're looking at the building science techniques, right, and building a house that's tighter, and you mentioned this, that as we're dealing with air leakage and we're sealing these gaps, right, we're losing energy or air, moisture. I mean, all these things come into play as this home's tighter. And as you mentioned, we're still living in the home. We're still breathing. You're still running the mechanical. There's still moisture being put through that mechanical system into the house. And then as you turn on the hood, right, or the vent to your range as you're cooking some bacon in the morning, whatever it may be, or turn that on, you have to have makeup area. You still have to have that balance in the house so you don't have an issue with air pressure. And then, as you mentioned, that's cut through ventilation. And so all these things are playing a role because you have to equalize the house. Absolutely.
Yeah. So it's always funny when talking with homeowners who don't understand how their home works, right? For example, I was working with a builder, and he goes, "Hey, this guy, he's somehow smelling like waste in his house, and it's this bachelor guy, bought a 2-story house. His HVAC was, I didn't design it, but I worked with the builder to make sure it was airtight. So he's like, hey, look, I think it's too tight. You know, bachelor guy, 2-story home, lives on the first floor, basically never goes upstairs. And I go upstairs and I run the water, right? So I run the water in the sink, I run the water in the tub, and I flush toilets. And then I leave, and I tell the builder, all right, I'm done. I fixed the issue. And he goes, I don't get it. All you did was like run water and flush. I'm like, yeah, he never goes upstairs. So he has this great HVAC system, and it's sucking in the smell from the sewer because his traps were dry because he never runs water.
Yeah.
He never ran water. And
so walk through that, because this is something I deal with that like people don't understand, just like a dry P trap or if you're not running water.
Yeah. So, you know, anything that water drains through is typically connected to the sewer, whether it be city, septic, whatever it is for that person or homeowner. If you're not using things in climates, things tend to dry, right? So if you put water in a cup and leave it there for 5 or 6 days, it'll evaporate over time. So what's happening is your P traps, or your traps in general, end up becoming dry, evaporating, and then that water it does two things. One, it kind of creates like a little vacuum that when you flush, it helps pull some of the water, but it also stops air. So when you're running your system and it's properly balanced, it has to maintain a certain pressure. But misbalancing these systems can affect the indoor air quality because that trap is just all of a sudden dry and it's just pulling in the smell of septic into a home, right? So sometimes it's as simple as, oh yeah, how do you use your house can dictate how your HVAC system is affected, right? So this just keeps going back to how we have to think about buildings, right? It's no longer, oh, my OSB failed, or oh, my insulation failed. It's, oh, the wall failed, and here's why, because it's a system. It's all relative to each other, and it all has to work together now.
So walk through HRV. You mentioned ERV, right? ERV, energy recovering ventilation, and that has to do with like the energy balance, as you mentioned. As homes are tighter, we have to have that makeup air essentially. What about HRV? Yeah,
so HRV is a heat recovery ventilator. It works in the same methodology that ERVs work, where it helps bring in fresh air, but it also recovers some of that. Heat recovery ventilators are a little bit slower on purpose to recover as much heat as possible in cold climates, right? So like if you were in Canada or Michigan, you have much colder air. So you don't want to drop, 20-degree air in a 60-degree space directly. What you do is you pass it through a thin damper system that they don't mix. They just pass it through each other. So that heat is basically escapes that hot air that's being pushed out the house is escaping and going into that cold air. So it's warming it up. So it's basically a way to dampen that system. And because of that, you are using less energy to heat that house now. So rather than dumping in that 20-degree air right into that space and having to heat it, you are preheating this air and then putting it into your house and mixing it. So in some climates, you may benefit from having both, right? Some you may benefit from having a single system. Some you may benefit from having both. You're not required, but you may benefit from having both. So like in areas where, like, let's say Texas, right? Hot, humid, an ERV in South Texas is pretty much all you're going to need. But in Dallas or Amarillo, where it snows quite a bit, at least once a year, it may benefit to have both, right? So during the summer, you have the ERV active, and then during the winter, you have that HRV active. So you could benefit from having both in some areas. It is a costly, it's cheaper, but it is a cost expense initially, but in the long run, it is such a benefit to your home.
Well, this goes into the importance of mechanical design. It's interesting because, I don't want to say heavy lifting, but one of the challenges as a builder is, I work with a vast array of designers, architects, and engineers. Okay. So, and I'm just speaking specifically to the architecture side, and some of them are really great, right? They're super involved in the mechanical side. They have great consultants they're working with. Some of them may be more the draftsman side. Like they're like, hey, I don't do any mechanical design. I don't do any like plumbing design. Like you can work on your plumber with that. Like I don't even need it for the permit with the city. So you're kind of on your own essentially. I'm not designing to that aspect. And so that's really where it's tough because how important is that mechanical design just to understand your climate zone as well as, just how the house is being built and constructed?
No, it's huge, right? So when you're just incorporating a single system for design alone, right? So let's say we're looking at structure, design. All of a sudden, the plumber has to come in and go, well, I can't put a duct from this side of the house to that side of the house because there's this big, gorgeous beam that you want exposed that I can't cut through. It's structural and it's, purposely designed, right? So it's just one of those things that when I speak with architects, a lot of them have to start becoming preliminary designers in MEP, right? Mechanical, electrical, and plumbing. So to really start focusing on how do I get the room that I designed on this side where my HVAC could be on the other side? And how do I get the duct over there? How to get the conditioned air over there? How to get water over there? So sometimes through the attic, sometimes it's through the floor, right? But the idea, the kind of idea of just doing one and not including others really can hamper the way a building performs, right? And when building these complex and gorgeous rooms, if you're not looking at throw initially and it's an afterthought, well, everything else is an afterthought. Comfort's going to be an afterthought. Air quality is going to be an afterthought because they're not incorporating, if I build this dome, ceiling here and if I just put a register here and kind of just cover the area, are you really getting to where you need to, or are you just kind of just putting it somewhere knowing that you need air conditioning there? So it really starts affecting the way you design, and it could actually increase the load on the HVAC unit itself.
See, this is fascinating because as you mentioned that, I look at some of the homes we're building and that modern design is very popular, not just here in Arizona, but throughout the U.S. So with that, it's very complicated because we're doing flat roofs. You're dealing with a very small truss system. So it's not like we have a very steep pitch and like a more transitional French country home where you have plenty of room for duct work. And, this is really important, as you mentioned, with the throw of just the cool air, especially in the summer, and what overhangs do we have to protect the house. And, when you don't have an architect that's either doing BIM modeling, and they're modeling the house to say, okay, this design looks great, but where are we putting the ductwork and how are we going to make this function? That's the challenge we deal with as builders.
Yeah, it's huge. I work with the architect, and I also work with the installers, right? The people who actually build it. I've trained framers. I mean, that's literally that's how I met you, right? I was training your sheathing people to install our product there, right? And when working with everybody, I always try to aid them in understanding that while this is your part is important because it affects the people behind you. And then the people behind you, if they're being affected by your work, they're going to affect the people behind them. And it's just this conglomeration of, it's basically a bad domino effect. And then, of course, everyone likes to point the finger, but it all comes out with design. If the architect can show exactly what he wants and understand the installation practice based off of that, or how they want to cool a room or design a room or light being let into a room, it can really help incorporate the framing, the HVAC. Sound is also a thing that we haven't even talked about, right? So how is this design affecting the sound in that room, and how is it transferring in the building or even outside, right? How is the outside being affected through walls and stuff? So it really helps if you get everyone on the same page. I know that's a big ask because, architects almost never see the installers because that's typically GC. But if you can incorporate the design with the people who are working it, you tend to get a better outcome in general.
Yeah, it's so true. And it's interesting. Earlier in this conversation, even in regard to mechanical design, MEP, as you mentioned, the foundation's a bigger part. And, up north, as you said, that northern climates are a little bit more, I don't want to say advanced, but they're ahead of the curve, if you will, because they're used to insulating slabs, which we're doing our first one now, truth be told, on Mark's house. But how does that play a role, from foundation prep, buried ducts, things of this manner?
Yeah, so those are great questions. So one of the things, so let's start with foundation, right? So foundation is basically it's basically a thermal sink, right? It ends up being very cyclical to what the ground is. But what happens is during cold times, there is this weird transition point where that slab stays cooler as it becomes spring and it starts warming up. And then that warmth that it's being absorbed from the outside is staying inside. So as it cools, it actually helps your home a little bit. But it's not a lot. It's not enough to say this is the biggest benefit. What ends up happening is the exposed structure on the exterior, direct sun, is what really affects the slab edge. It can affect the comfort of a house. It could drive some materials to buckle. Like let's say you're using this gorgeous wood, and that heat is driving moisture through your cement, through your concrete, through your foundation into your wood that's now cupping because of heat transfer, right? So if we're going to do something and make sure that we do it right, especially around high-level materials, we need to focus on the small things. Slab edge is going to help with that significantly. And then like for HVAC design, when you're looking at getting such a high-level efficiency duct, we tend to hang our ducts in the middle of an attic, right? So in like let's talk about Texas. We put our HVAC unit in the attic, and then we stick our ducts in there. It could be anywhere between 100 to 120 to 140 degrees up there, and then we expect to have the coldest air coming out of that register that's 50 feet away, right? So by looking at things like putting the duct low, focusing on getting it to that room fast and covering it with insulation, you can get this really high efficient system with just ducts, right? And these are things that, while all building scientists are always going to say, put the ducts in the conditioned space, and I don't disagree, this is basically the next best option, right? It's a very semi-cost affordable methodology to get ducts into conditioned space. Ducts under insulation when they're already in the attic. There are some nuances based on code, location, stuff like that, but it is a great way to get high efficiency air conditioning in your home, as any builder, right? It's not specific to high end builders. This is any builder.
So do you see? I mean, as a building scientist, in all of your experience, do you ever have concern with buried ducts? And the reason I bring that up is like underground air. So here in our market in Phoenix, for example, early in my career, I worked on this. On a very notable project in town. And because of the design, to your point, they had this vaulted ceiling in the great room, very tight. There was no room to have any duct work. And so on that end of the home, everything was buried coming from underground. Have you ever seen concerns, installing that method as opposed to maybe looking at the mechanical design coming from a conditioned space?
Yes. So you always have to look at the way the ducts are installed, right? We could talk about the benefits of flex duct over metal ducts, and it really comes down to more on how you take care of the perimeter of it, right? So
maybe before I answer my question, I mean, you mentioned flex and metal duct. Is there a benefit or pro or con to either?
Yeah. So the pro to metal ducts is that you have you're not throwing these ducts everywhere. They are a path design system, right? So if I need 10 feet of metal duct, I'm not going to bring 20 feet and cut a little bit. You're purposely designing and then focusing on wrapping this duct, right? So you're really intending to be as high efficiency as possible. Inside, it's the smoothest you'll get in a duct, right? Rather than a flex duct that's corrugated. It has a bunch of dampers, fins. So there's noise benefits with having a smooth surface rather than an accordion surface. For those who don't understand the spiral effect of it, but so there's different benefits. If someone said, "Hey Neil, here's money, go build your best duct system," I would probably do a hybrid. I would probably do a metal duct core and then pull flex duct as short as possible from the core to that location, just because I know that I'm never going to be able to design it to the T. And I know there's going to be some framing in the way that I have to get around. And the easiest way to do it would be a flex duct. So they both have their pros and cons, right? So with the metal duct, I have to now design, cut, and manufacture my own work around that framing. When flex duct, I can just extend it a little bit and maybe wrap around. Of course, bends are always going to be an issue. Tight corners are always going to be an issue. And then, condensation is the other issue in hot, humid climates, not so much arid climates. But like if you're really focusing on the care of the external insulation of both ducts, they'll perform well.
So then, going back to, and that's interesting. So at least I'm kind of doing it right, as you mentioned. So, because we do have some modern homes where they do have, the main trunk is metal rigid duct, and then we have, little branches, arms, if you will, some of the flex duct. But going back to the underground air issue, I mean, do you see issues with underground air? I mean, I'll just, without just the air quality or the building science, the envelope side, I do know one of the challenges, and we had this happen a couple times where you put the underground air in, and I think we did 34 homes, and 2 of them had this issue. But, if you're not careful in backfill, and as you're moving in, right, there was damage to, to the underground trunk system. And so that created some major issues where slabs poured, cabinetry's in, and now you're trying to, get through and find a solution there.
Yeah, so that's what I mean. You have to take care, right? So you have to make sure that things aren't crushing the insulation, large materials aren't touching it, like for an attic. Right, I want to make sure that my duct system, once installed, never is the path over something. Right, so I don't want to sit there and have to have an HVAC guy climb over the material, damaging the insulation. And same with underground. Right, I don't want that I don't want that ground or that the soil or aggregate starting to rub or fall on the insulation around the duct where it could hammer or pinch or something, causing flow issues. Right. The duct's going to react to its environment. So if you're not taking the most amount of care, you can tear it. And all of a sudden, now you're pouring conditioned air in a dry cavity, and you're naturally, throwing in some moisture. All of a sudden, you can get mold in an arid climate because you've exposed the actual conditioned cold air in a warm, unconditioned space, right? So taking care of it. And on top of that, I don't think it's your area is such an issue, but people have to worry about radon gas, and if they're not taking the proper care to wrap and prevent that gas from infiltrating into the duct, that also matters too, right? So it's attention to detail and care is what really can prevent a lot of issue in the future. I always work with installers, and I always have to explain to them that while they always feel like they're never getting paid enough, and I'm not here to argue for or against them,
right?
If they have to come back and repair something that if they spent 10 more minutes on taking care of, they would have made the money that they're complaining that they didn't make. So it's always about just stopping and making sure that you're just looking at things, making sure nothing's going to affect your work, because as soon as it does, you've lost any profitability if you thought you had it by coming back at your own dime.
Yeah, that's a really good point. And what's interesting, just as you mentioned, just the foresight, the thought, right? And this is what we're speaking about, just the planning of building science. And what I love too is, I mean, this is your role, right? You're working for a manufacturer that we use, and they have you on board full time because you have the experience and knowledge with this, Neil, and that you're helping them with that product innovation. And I've seen just in my, last few years, just that product innovation, how that's continued. And we're using a lot of this on our projects. And so how have you seen that advance? We're manufacturers now looking at this, and products they're bringing to the market that now are combating or at least assisting us builders and clients for that matter, right, in the sustainability of their homes.
Yeah, so that's a great question. Yeah, so like for LP, for example, we're coming out with continuous insulation solutions through the use of NovaCore, right? So we're adding to that wall structure. We're saying, hey, let's reduce thermal bridging. How do we do it? This is how. But we also have a board that provides structure, right? So it's kind of a 2-in-1. While we don't have a WRB on it, or weather-resistant barrier, it allows that builder, based on climate zone, to pick what they want and apply it right over it. Or like if you're building in an area that is much more sensitive to fire, a WUI zone is what we call them. So like in the Pacific Northwest or California, we have materials that are both structural and provide a fire barrier, right? So these things that we're looking at and continue to manufacture only provide either a cost savings or a benefit to the builder, right? So insulation companies have the benefit of saying, hey, look, we know that, let's say Flame Block, one of our products is on there. It's a cementitious product on a structural OSB board, and it could be single-sided, it could be double-sided. So we can replace gypsum in that area, and it could be structural. So we provide some fire resistance, some structure. And, for flooring, when designing crawl spaces or having areas that are exposed for long times, we have like products like Legacy that allow a builder to take their time and make sure they're building right. So as it rains or it gets conditioned, we have, a sand warranty on there. It allows that builder to take their time and not have to worry about quickly drying stuff in, and helps them plan and helps them plan on what to do in that home, right? If they need to adjust something, they can, so they don't have to hurry up and cover stuff up, and then they have to go, oh no, I have to tear down this section of the wall and repair it, right? And we have products like WeatherLogic, right? The product that you and me worked on, and including the new tape, which I'm hoping you've seen.
We have, yeah. We have some.
Yeah. So it's a weather-resistant barrier on a structural sheathing board, right? So you attach it in a certain manner, and we have a brand new great tape. I mean, it is, in my opinion, dealing with tapes in the industry, it's probably the best out there now.
So now, do you have any? Because even on the WeatherLogic, we use some of the new tape, right, that was sent out on Mark La Liberte's house, but we also have some membrane, right, like a liquid membrane. I mean, is there a preference to either liquid membrane or tape, or is it mostly just making sure you understand the protocol for install?
No, so from a building perspective, it's always better to do a liquid applied, right? It's a lot more detailed. It takes more time, but that time and effort putting into it, you tend to cover everything much better. Tape is a great system. It works well. Just that it doesn't give you that amount of time and effort when you're sitting there rolling it on or applying it and then squeegeeing it on our system. You're not going to be able to see whether you're looking at the nail and, oh wow, did I cover the nail right, or did I puncture that membrane? Here you can keep adding with that liquid, which is a little bit better. And on top of that, you never have to worry about sequencing, right? So one of the things that with tape, you always have to worry about shingling. And when I talk about shingling, it's the way that water drains. So you never want to create a shelf for water to sit on that tape. You always want it to drain over itself. So that's one of the best things about like the liquid applied is you don't have to worry about where you start and where you finish. Or if you have to repair, you never have to worry about, oh, well, I have this tape that already here. How do I incorporate a new tape or a patch or repair? So stuff like that.
And I love that you share that because, I mean, it's the layers, right? Because really for the tape to be effective, and you went through this extensively. When you came out and trained our crews, this is exactly like the method to install the pattern, the sequencing so that it's done properly and it all drains, whereas, liquid applied, it is a little bit more, I don't want to say dummy proof, but it's a little bit easier that way. But as far as you mentioned this early on too, with like the Legacy, and I was speaking with Kyle Steppenhorst about this, especially at the Builder Show quite extensively, is that, even for us, it doesn't rain a whole lot, but when it rains really hard. And I'm not in Oregon. I'm not in parts of the country, where it's going to rain all the time. But the reality is, you put OSB, like a normal OSB in here, and it's going to get saturated. It's going to bend. It's going to warp. I mean, there's a lot of issues. And even for me, if I'm framing in July, August, September, my monsoon season, we're exposed to those elements. And it's really hard, especially on these bigger homes, 10,000 square feet plus, to get them enclosed quickly to protect the product. Whereas you have something like Legacy that now really solves that issue in wetter climates, or, as a building process, maybe a little bit longer because we don't have enough subs, right?
Yeah. Labor is such an issue with the situation today. But yeah, so what, like I said, one of the benefits of our systems is we plan for that builder. We plan understanding the delays. We plan understanding how the material works in the home.
And so what are, at WeatherLogic, I mean, right now we're using Flame Block, and you mentioned this, that it has, so just to explain what that is, we're using that on our net zero home and for any of the home that's facing the desert where there could be a fire essentially coming up. And so really it's 2-in-1 for us, that we install the structural component like the OSB, but it has it integrated, as you mentioned, it has a layer there. There's the Flame Block that prevents, gives us that fire rating, if by chance there's a fire that comes from the desert.
Yeah, absolutely. So it just helps aid your wall, right? Because we can talk about that component all day long, but it becomes a system, right? So you can add some sort of mineral wool on the interior and increase that fire rating of that wall. So it's basically a great way to buffer between an emergency and get out of your house, right? So if that, If your house next door is on fire and it's coming your way and you've got to buckle up and grab stuff and go, it's going to give you that added comfort to be able to grab your priority items and then bail while protecting your house potentially if they can control like a wildfire next to you and prevent spread.
So what's funny, Nils, as you're speaking in this conversation, I mean, this intrigues me. I love this stuff I could talk about all day. And what's funny is, having grown up in the industry, I grew up in California and I worked as an electrician. I wanted to get into, general contracting, get into building these homes. And, I saw from my side as, you get to build these amazing homes or on these amazing projects, see them come from the ground up to design and building. And I look at you and I'm like, how did you even know? Like, what puts you in this career? Because the more I speak with building scientists, like, it's just fascinating the amount of information and knowledge and how complex it is. And it makes me really think about my business. And we mentioned this early on, that how complex building is. And we don't even realize, did you always have a passion for this? I mean, how did you get into building science or even know that, hey, there's actually a career for me down this road of this avenue?
So it's funny you mentioned that. So I come from a big family. My brother had a construction company, and I would work with him during the summers or like sometimes weekends. And I was like, man, this is really hard labor. I want to do something different. So I went and became an engineer and an architectural engineer of all things. And right out of college, I got hired by Owens Corning, and I got trained by, honestly, some of the best building scientists out there. Achilles Karagiozis, Mika Solovata, Marcus Bianchi. These guys that I worked with have really trained me. And of course, I had the building knowledge already, right? From working summers and weekends on building both commercial, residential, you name it, I did it. I mean, I think I started at the age of 12 sweeping screws off of 5-story warehouses. Like, that's where I started. And, from there, I started doing more insulating metal buildings, and I started doing more repairing roofs. It's just one of those things that I just tend to be in my comfort zone. And when I left and went to college thinking that I'll never be in, construction, doing something with engineering, and I ended up being right back at it. It's just one of those things that's just kind of looped back. So the funny story here is you want to get out of building, want to get out of construction labor side, you go into engineering. What did you focus on in engineering? So I became an architectural engineer, and at my school, we were probably we were a pilot program. And the funny thing about that is we had this mixture of solar design, HVAC design, concrete, steel, material sciences that most people don't get. And we were being taught at really a graduate level because that's all the professors they could get to teach our courses were graduate level teachers. And so I have this weird understanding of HVAC system that most people leaving like a bachelor's degree doesn't. Same with design and implementation and even architecture. One of my professors who really took me under his wing was an architect professor. And while he went to go get his doctorate, I was an undergrad student teaching his, helped a teacher aiding his courses. So I got to experience a lot in such a short amount of time at school that it really just kind of honed my skill at building science in general. And building science was much more of a happy accident for me. So have you found any resistance in your career? I mean, you went to Owens Corning, now you're with LP, right? You've had this amazing journey. And as you mentioned, you're mentored, by some incredible building science, experts, right, in our industry. What frustrates you now, or maybe it's both. You probably have some things that frustrate you trying to get maybe, our industry that's very slow to change, very slow to adapt. So what frustrates you that way? But at the same time, what excites you maybe working with LP or, seeing kind of the movement that's happening? Yeah, no. So there's, frustration's always going to be there, but it's never one thing, right? It's an accumulation of things. It's like, oh, look, building science has really shown how to improve this. But then you get the installers like, oh, that's not how I build. That's not how I used to build. It's like, yeah, I get it. Things change. And even in industry, right, if we can improve our process to build better materials, you'll still get some of that feedback even in manufacturing. It's, oh, well, that's not what I'm used to doing. It's like, yeah, that we're learning together. Let's move forward kind of thing. And same with building. And then overall, what really excites me is the opportunity at LP for what building science can't do and how much we can grow. So I'm just excited to be here. I'm excited to do a lot of things with Louisiana-Pacific, and I think it's such a good opportunity in my career.
How often do you get to work with the builder? I know you came out for us to do training, and so I would assume your role is pretty active. I mean, how often you get to be out there and be in the field with the installers and the contractors?
So not as often anymore. Mine's more kind of high level, making sure the material works based on climate zone. So like, we're launching products, and I'm in the background making sure that the product we're launching in that climate zone works, right? So I'm kind of high level. I can work with builders. I've done it my whole career. So working with you, it's great, and it's an opportunity that I love, and it just doesn't happen as often. But there's nothing wrong with like a builder saying, "Hey, Neil, I have questions, and maybe we can work high level."
And then from that side, not just from you overseeing the builders, but as you're doing this testing with climate zones, with product, and I'm sure you're working in a lab and you're running formulas in a lot of different avenues. How does the building products we install, whether it be different flooring products, whether it be different types of wood species we're bringing into the home, maybe we're bringing furniture, right, and VOC that we're integrating into the house, and so how. And we talked about this earlier, the substrates we're putting on. I mean, how are you trying to factor how all these different products now impact the building science that you're creating and the products that you're already working on?
Yeah, so there's a couple of things that we're doing. I can talk about the programs. We're using some WUFI modeling, which is a hydrothermal model. We're looking at how it affects the comfort using some passive systems, or some sort of advanced, BIM modeling. So all these things that take into all these items that we're modeling are really focused in on how the product affects that wall, right? So if we're making a certain type of flooring system, how does that crawl space, how does the slab underneath it affect that, which then affects the condition inside of that space? And then on top of that, we're also taking stuff like inside, saying, well, I know that the use of this area or the use of this room could be a gym for somebody, or could be just a bedroom, an office, right? So you and me are the biggest variables inside a space. We don't know exactly how we're using it, but there's some calculations, there's some understanding of what buildings can be used for. And based off of that, I know how that material will work, or what climate zone not to put it in, right? So that's really key, is finding the climate zone not to put it in. So like, let's talk about like attics, right? So when I'm looking at like all the opportunities we have, TechShield. TechShield is a great product. It's a radiant barrier attached to an OSB roof material, and it works great in climate zone 1, 2, and 3. Basically, the southern belt and smile are down, and areas up above it, it doesn't work so well. It could condensate. So we're looking at the benefits of it coming up or coming down, and how it affects the overall energy of the house, or how it affects the potential condensation on surfaces, even in the attic. So we're looking at all these things that aren't simple, right? They're not, I can plug and chug in a model. I have to plug, model, and then understand what I did.
It's amazing. I mean, it's fascinating just hearing all this information, everything you're doing, Neil, and just all the different scenarios you have to work through. So what do you do for fun outside of this, outside of the building science?
Oh, so you're going to laugh, but I like to do a lot of woodworking. So I've no joke, YouTube has taught me how to do woodworking. So I find a project, my first couple ones are rough, but over time I've gotten better, skilled, and woodworking. I enjoy spending time with my family. I have a 5-year-old son, I have a wife, and so that's pretty much it right now.
Yeah, busy as can be, like all of us. So, yeah. I mean, you've been amazing, Neil, and I love all the information you shared. So what's upcoming and exciting?
One of our biggest projects is NovaCore. I think that's going to be exciting. I think that's going to help the builders who are looking for prescriptive solutions for walls, adding insulation. I think the flame block for the WUI zones, and then the Weather Logic and the Gen 3 tape, I think is going to knock a lot of people's socks off.
Can't wait to see. And so for those that are listening, and where can they follow you? Where can they find you, especially as we see this the new product?
Yeah, sure. So if they want to reach out to me, you can look me up through LinkedIn, Neil Freidberg, or you can look through email me via Louisiana-Pacific. So it's neil.freidberg@lpcorp.com. But yeah, otherwise, I'm I'm pretty easy to find. There's not too many Neil Freidbergs around.
Yeah, there's not. Well, we'll make sure we have you tagged in the show notes here. Neil, you've been amazing. Can't thank you enough for sharing some of your building science knowledge with us today.
Yeah, of course.